Are we ready to go? So I'm not going to be as interesting as Slav and all that. So anyways, we're just going to go over starters a little bit today. Everybody always has questions about wiring starters. So I brought a few examples of things, and I'll show you how to do some basic wiring of them. But a starter is generally something that's designed to run a motor. So it's a set of contacts, it's a contactor, and then you generally have something that's there designed to sense the current in the motor. So this is a manual starter, so it's basically just a push button switch. Okay, I can actually actuate it, but this is an Allen Bradley 609. It doesn't have any heaters in it right now, but I can pass this around if anybody wants to look at it. So the ones that we're actually looking at are magnetic starters. So a starter is basically composed of a magnetic contactor. I can get this piece off now. The contactor piece. So this is controlling the voltage to the motor, and that's coupled to an overload block. This is the element that senses what the current draw on the motor. So that's just on the Allen Bradleys. These are just composite devices. That's just going on the bottom. And then it has a set of auxiliary contacts that are used to control the control circuit. So they're all based on a bunch of real standard components. A lot of it's all mix and match together. You can change the functionality of things by adding pieces, and if you need to do other different kinds of control and stuff. So the way this is set up, 3 separate starters. We'll just do a simple 3-wire one here first. These are all 120 volt coils. So that's something a lot of people run into. So I needed to have a control transformer on here because the shop here is 240 volt 3-phase. So the power's coming off of here, 3-phase power into this terminal strip. There's a 240 to 120 volt control transformer here. So I got the power coming off of there. So this is the power lead. So that's the power that we'll use to do any of these. 3 phases coming into the top. So this is L1, L2, L3. And then they're wired through the bottom. So for most things on machines we're running with magnetic contactors, people are setting them up with what's called 3-wire control. So that's just your standard start-stop type station. And so these are all fairly generic from all the different manufacturers. These are old Allen Bradley ones, which are just integrated ones. They just are single function start-stop. But a lot of things that you'll find are made up of a bunch of different operator buttons that can be set up for different functions, and so you can change out the different buttons and what you're looking to do with it. So I'll show a few of them. So in all the different manufacturers, this stuff is all Allen Bradley stuff. Like I said, these are all 30 millimeter operators. There's 30 millimeter, 22, and there's little 16s. These are all the standard NEMA size, or the 30 millimeter. The 22s are used for a lot of NEMA stuff, but those are actually from the IEC standard, so that's a European standard. But within the 30 millimeter stuff, it's all fairly similar between the manufacturers. But they're all designed to be they're just a basic operator body. This has got nothing on it, and you can change the functionality of this by all the different contact sets you can buy to put on these. So if you're looking for these, a lot of times you look at the catalog numbers or what you find on eBay, you need to know all the little pieces that are married together and whether it's actually has the functionality you want. So this is a push-pull operator. So it's a maintained contact, not just a momentary like you use on the start-stop. And so this, you can put a contact block set on it. And these all just screw right on the back. If my hands don't shake. And so then that gives me the switching control. So this one is a normally closed contact set. But so these things can all be built up then. So this is one that's got a set of normally closed, normally open. It's also a push-pull operator. And then if I need to do something else, if I'm controlling multiple devices, these things can actually be stacked up and you can put multiple decks of them on. So you can have all kinds of different functionality. So like doing the two-speed starter over there. So I'll just pass a couple of these around.
There's 30 millimeters at the size of the mounting hole.
Yeah, that's the size of the mounting hole. So those go in these standard little operator boxes. So in the same line, you can get all this is a pilot light. You know, pilot lights are specific. So this one's 120 volt. You can get them there 24 volt or whatever. Some have little transformers built into them. Okay, so on the starter side of the 3-wire, I don't know if anybody can see this. This is usually how things are laid out of what they show you how to hook them up. So the standard convention is you're always going from the line one. The first thing you're going through is the stop button. So this is all just in series. So it's just the normally closed stop button in series with the normally open start button, in series with the coil, and then the overloads, and then to the other side of the power. The only thing in here then, so on that side of it, if we just push the button, it's going to close the circuit, and the contactor is going to close, and the motor is going to run. But if we release the start button, nothing's going to happen. So the auxiliary contact set then is actuated by the contactor. So when it closes it, it now completes the circuit and holds the control circuit shut. And when you release the button, everything's continuous. It doesn't release until you push the stop button. So for standard 3-wire control, if you look at this, this is numbered. And this is a standard convention on most starter wiring. You start at line 1 is terminal 1. In the middle of this is terminal 2, labeled 2 here. And then terminal 3, and on, practically every starter you look at, there'll be a terminal 2 and a terminal 3, and off of line 1 is terminal 1. And then if you look at on the switches, they're usually labeled. The common terminal between the start and the stop is terminal 2. It's got a little 2 on here. And then terminal 1 goes to the stop button, terminal 3 goes to the other side of the start button. So on here, let's see, I get the right green. I don't have very good, since I'm using just SO cable here, I've got to deal with having green cables. And so on these Allen Bradley ones, since I'm running off of a control transformer, normally you'd have power coming off of one of your lines coming in on the top side, the unswitched line. Since I'm using a control terminal, the one line is always going to come off of the overload side going back to the line. But so this is a little tie point terminal that they supply. Sometimes these are on there, sometimes they're not. So this is a little add-on piece right here on each of these that allows you to have a place to tie the common for the power when you're using a transformer. And my common terminal on here is the white one, so that's 2. That's just going down here to terminal 2. And the black one is 3. Turn on the power and we have start, stop. One thing that a lot of people aren't aware of, since the way this is set up, it's always waiting for this input from the start to engage the contactor. But the contactor closes the auxiliary contacts. So sometimes if you're working on something and you don't realize it, you can actually go in and actuate the contactor. If you just bump that lever, your motor is going to start without touching the start button. So most of these types of starters rely on gravity. They're all designed to be mounted upright. So if you're bench testing this or whatever and you have this in a box and you jar it on your bench, you can actually jar that the armature hard enough that it'll close and your motor will start. So you got to be, that's something, like I said, they're all designed to be run vertical because they rely on gravity for some of the force to pull them down. So you can, drop the box and your motor will start.
Hey, Ray,
so
there was something going around the internet a few years ago where somebody said they had a table saw with a mag starter on it. They dropped a piece of wood and it hit the starter itself, not the start button, but just the starter, and it started the motor.
It could. I mean, if you jarred this hard enough, it doesn't take much to lift that up, and it closes at a set of auxiliary contacts,
right,
and it holds it shut. I mean, that's...
I do think that was an IEC starter.
Right.
Yeah.
That would make more sense, yeah.
Yeah.
Yeah. Those are more prone to that anyway.
Yep.
The cheap ones are really prone to that.
Right.
So the one thing that 3-wire control gives you, and this is preferable on most machinery, is it gives you under voltage release. So if I drop the power and turn it back on, that device is not going to start. So the other side of it is if what's called 2-wire control. That's where you just have something, it's not going to be a start button, but it's going to be some kind of input device, like a float switch, a pressure switch on your air compressor, or whatever. It's the thermostat, whatever, it calls for pressure. It just closes the contactor directly. And so in that type of scenario, you don't have any under voltage release. When your power comes back on, if it's calling for pressure, it's going to start. So there are ways of provisioning things for that. You can have a separate little, I was going to set something up here, just a simple little industrial control relay. You can just set up a secondary little control circuit so that, like on your air compressor, if you want it to run automatically, you can just go up and have it. So you press the start button, it energizes the circuit, it holds it as long as there's power there, the thing can cycle on and off. But if you lose power, the thing's off and it's not going to start again until you go set that reset button and bring it back up. And that's actually a good way to control things. Say you want to run a 3-phase air compressor off of a phase converter. So if your phase converter is set up so that, you start it and you got your air compressor connect to it, and the only thing you have is a switch like this over on it to turn it on and off. You may have forgot to turn it off. That thing's going to be in line with your phase converter, depending on the design. And it's either going to auto start, or the phase converter is going to try to start your compressor at the same time as well. So that's a way of handling that. If you want to have a mag starter on your compressor, you can have a secondary little control circuit so that you can provide that dropout protection, or in that way it's just a way that you start it when you want to use it. And that's also something, you don't run across these a lot, but this one, okay, so this is a Bolton 609 starter, but it actually is a 609U. And it has this little set of terminals over here on the side. And the nice thing about 609s is you can use them for any voltage. You know, you can control a 120 volt motor, 240 volt 3-phase, 480, these are good to 600 volts. But if you get a 609U, it actually has a coil label down here because it has a little under voltage release dropout coil on it. So this one, power goes off of from 2 of the input terminals, and if it's in stop mode, you're fine, you turn it on, you run, it's just like a regular manual starter, start-stop. But if it's under power and you lose voltage, this little coil is going to trip it, and the only way to get it to start again is you have to cycle through an off cycle, a stop and a start. So these are really common on school machines where they were required to add under voltage release or whatever. So you got to be careful when getting these, because if you got one that has the wrong voltage on it, it's not, you don't have the benefits of the manual starter anymore. It's voltage specific. The nice thing about these as well is now you can use this control circuit out here, and I could take this and I could wire in like one of these maintained emergency stops. So I can have the manual starter on my machine, but I could have an emergency stop button up somewhere. So this, if I break this circuit here, you know, it's just got to be put in line with that 2 leads. Now you have under voltage release on a manual starter. So any questions, Mark?
So you've got the 3-wire control that you're describing, and if you want to put an e-stop button in, let's say on a lathe
Yep.
at the far end, maybe, you could use a maintained button or a normally closed button.
You could use,
Put it in parallel
so
with your...
in that scenario here, I was going to have this set up so I could project it or whatever. So this right here is the stop start station. But the nice thing about the setup of this, with the stop always in the beginning part of the circuit, so if you follow the convention, it's very easy to add more stop buttons because all they are is wired in series. You just add one in here, and it could be, it doesn't have to be a maintained one, it could just be a regular stop button. You know, you can just have a button that you just want to hit.
As long as it's normally closed.
Yeah, normally closed.
Okay.
You got to be careful on the maintained ones as to what, since they're not, you know, a momentary thing, you got to be careful as to what you get as to what you desire as to what the operation is. That one's actually busted. When it's pulled out and when it's pushed in. So when it's pulled out is the state of what these are for a momentary one. So if it's a normally closed contact, then it's closed when this is out, which is probably what you want for an emergency stop, because you want to hit the button and open the contacts. So these are also nice. You know, if you're controlling multiple motors or something, you can have this upstream of multiple contactors that nothing's going to run until you know, pull this as the reset, you arm the whole thing, and then you can control the other motors, and then one stop can control all of the motors on the device. This is the kind of starter that you mainly find. These have the eutectic overloads.
I was going to say, right?
Figures out. Right. Make it all safe. I'll stick my finger in it. Let me get my tongue across that point. So these are eutectic overloads. So what these are is a little brass barrel, and they're filled with a eutectic alloy that has a very specific melting point. And there's a shaft through it and a little ratchet wheel on it. So this is the end of the spindle, and it's designed so the heater values. This is just a little coil of wire, and these are all specifically designed so that at a certain current, the temperature of this is going to go up. It's going to melt that solder. It's going to release this little barrel, and this thing is going to spin free, and that's going to then trip this overload block. So a lot of people look at these things like they're some kind of fuse element or whatever. And an overload block, when it's got the heaters in it, it always has a current path through it. This thing does not break the circuit at all, break the actual load circuit. All it's doing is, it's a set of relay contacts, so when this thing trips, it's designed to trip the control circuit. But there's always continuity across these things. And then on the later ones, like on the 509s, they're designed so that you can't jumper these or defeat them in any way, because there's these little ratchet pawls down in there, and all of the positions have to be occupied. And in Allen Bradley, if you look at their heater charts, they never really seem to make much sense. You know, it's very nonlinear, but all of the values that they show for current are all pretty much empirically derived values, and they're all for a specific set of conditions. So there may be one set of heater charts that are for this scenario where you got a bunch of starters and a control thing. This is an open configuration, so it's open to the air. There'll be another set of values specifically if it's in a NEMA 1 can. And those are usually, you know, if you get one and everything's intact, the proper chart is going to be in the can. But if you're buying a starter and putting things together and changing one out in another can, you got to get the right set. They're all really close, but if you look at them, they all differ by, you know, up to 10% or so, depending on the scenario. And they're also then, since it's all empirical, it's all derived from how fast this thing heats and how fast it can dissipate it, as to what temperature this thing is going to get, to the point where it gets hot enough to actually trip that overload. So the scenario where you want to run this and run a single phase motor off of it, say you're running a 240 single phase, the way that you need to do them on the Allen Bradley side is you have to have all three of them populated to have continuity, but you also have to have current going through all of them. So if you look at their single phase wiring, they wire up through one, back through the other, and down. So it's really confusing looking. But by doing that, they're running the same current on the motor leg through both of these starter positions that's controlling one leg, and also through the other. So the heating value that was determined for those charts is now still fulfilled because you're heating all these positions. If one of them is just sitting there cold, then it's not going to heat at the same rate, and the value doesn't make sense. Other starter manufacturers actually just give a current rating on them. Allen Bradley's kind of weird in the way that they do it.
What's the duty cycle on one of those overload devices, as far as how many times can it actually melt the solder?
I don't know that there's really a lifetime in terms of. I have seen one that was failed, that would spin cold, that I've ever had, but I don't know. I don't think there is really a number of operation limit on them.
So when the solder melts, it actually can't go anywhere. It's all captured.
No, it's a captive little tube, and it just spins. And the design of most motor starter overload blocks is so that they mimic the characteristics of a motor. So if you're looking at, in Article 430, which is for motors, there's a clear distinction between what you're doing for your circuit protection and what you're doing for overload and overcurrent protection on your motor. So the problem is you can get, dual element fuses that are well tuned to the characteristics of a motor. So they have, really short interrupt capacity for short circuit, but they can, they can run for numbers of, large numbers of seconds, at moderate overload without tripping. But they're really expensive, as compared to, obviously buying these things new but they're expensive to replace. But so the overload side of this is actually designed to mimic the heating characteristics of a motor. So it allows you to run at overload and for a long period of time, in terms of minutes. What is it, category 10 or whatever, it has to be able to run for 10 seconds at 600% of its rated value. And the curve is very nonlinear. But any other questions so far?
The heaters you were showing us, those are the W series heaters?
Yep. Where did I put it? Yeah, these are Allen Bradley W. The predecessor to them was the N series, If you have old 709s, these have actually been around, I think, since the mid-60s, I think is when Bulletin 509s came out. So there's still piles and piles of old Allen Bradley 709s around. Or the older variant of the 609. I don't know why they didn't change the number on it, but they've made the 609 for like 6 decades. And, you know, completely different. And the old 609s, and, you know, usually in the black cans, take the Type N heaters. But if you have any of the 709s that are Series K or later, you can actually take the spindle out of it, out of the starter. And the only difference between the N's and the W's is the spindle is built into the W, and the N is just the heater element. So this part is actually part of the overload relay on the older types. So if you have any 709s that are Series K or later, the last part of the lifetime of them, you can actually remove the spindle off of the overload block and replace it with a Type W heater. And then there's a whole other chart of heater values that go with that for when it's used in those type. So most people have probably seen those. The nice thing about Allen Bradley is you can have, you know, a starter from 60 years ago and you can still find heaters for it. You know, trying to find for some old GEs and other brands, it's almost impossible to find heaters unless you know somebody that's got bins full of them or something, right? You know, so they're well documented, and it's a lot easier to find parts for. And they're made that almost everything on them is replaceable. I mean, that's typical of the NEMA ones. Everything, it's all modular, the contacts are all replaceable, the coils, all the pieces like I showed, you know, it's all components that all just bolt together. The IEC ones are, you know, pretty much fail throwaway. They're not designed to have anything done to them. You know, they're just all potted together, and they're not really designed for the same duty cycles.
You spoke about wiring these for single phase and having to have the power to both heaters. How do you do that in a three-phase contactor with both coupled like this?
If you have single phase coming in and you're just coming into 2 legs,
Yeah.
one wire comes through, the overload down here goes back up to the top and goes through. So it's just the same current's going to be going through all 3 of them.
Run it back through the contactor as well as the heater wire.
Yeah, you just one wire off of here, goes up to the top and comes through. Not all manufacturers, you know, that's not the way that they design them. But that's specific on the Allen Bradley side because that's the way their values are tuned, you know, specifically for what you look up in that chart, is that all spots are occupied. And then if you have an Allen Bradley single phase one, they make ones that are made for 120 volts that only have a single heater. And they make ones that have 2 heater spaces for 240 volt singles. They're not very common. And you can easily use the other ones, so.
Oh, you can fairly careless and leave it.
Yeah, yeah. And I even had the good example here this morning. I plugged it in, the extension cord that I brought, one of them, all of a sudden the motor wouldn't start with single phase, and because I didn't have continuity through one of the leads on that extension cord, and the motor wouldn't start. But since it was coming off the control transformer, I had power through the 2 leads that I did have power on, and it tripped the overloads on the starter because the motor is sitting here trying to start single phase and kicked off. Did exactly what it was supposed to. It would have been a good part of the demo. I'm glad that didn't happen.
If you know what it was, you could tell us right away. If you'd known what it was right away, you could tell us. Otherwise, it'd be just embarrassing.
Yeah, and it would have really been embarrassing if I would have like popped the fuse on the control transformer or one of the ones in there because I didn't bring any spares for those.
So what's that second?
Okay, so the second one here, this is also a Bulletin 509, but it has a solid state overload block on it. So this is really kind of, it's a NEMA rated starter, but this is actually much more of an IEC type of device in here. Allen Bradley's really kind of shifted now. They've got, I think, it's 300 series or whatever. They have a kind of a crossover lower price NEMA/IEC lineup now. I mean, the 509s, if going and buying these new, like we gotta buy these at the university or whatever, they'll only put in new stuff, they won't reuse anything, and they're expensive as hell. You know, any of us have ever gone out and bought, you know, any of these things new. I mean, I never paid more than $30 for any of these, but you know, they're hundreds and hundreds of dollars. But this is actually a solid state block, and you can set the overload current on it. It's just got a dial on it. And it actually, so like I said, in the NEMA world, it's very consistent in the numbering, you know, the terminal numbering. It's all made to be easy to hook up, not think much about it. You know, it's terminal 2, terminal 3. And this is actually marked with terminal 95, 96, 97, 98, which are actually standard IEC markings for the normally open and normally closed contacts on the overload block. The one next to it here, I brought as an example, is a Bulletin 520 2-speed separate winding starter. So if you look at it, it looks a lot like the other ones, and in typical Allen Bradley fashion, it's made completely out of the same components. So it's got two 509s, it's got a set of just jumper bars here that connect the input phase of each starter together. So you got power coming into the top here. It's also brought over to the second contactor. You need a lot more control circuit logic to be able to manage the two speeds, the two contactors independently. So there's a bunch of extra of those auxiliary contact blocks, these right here. So there's actually, there's 2 of them on here, and these are actually a double-decker one that has a normally open and a normally closed. So these are, like they're Bulletin 595. So like when I built my phase converter, the whole thing was all, it's got an input contactor, an output contactor. It also has timers and stuff, so it sequences between firing the input contactor, starting the motor. It has a delay, and then it fires the output. And it's all done with just relays, industrial relays, and it required a few extra of these little contact blocks on the main starters and stuff. So I mean, they're easy to find if you know what the parts that you're looking for. I mean, that's the whole problem the Allen Bradley side is deciphering all the numbers and going on eBay and actually finding the right piece. And when I built my phase converter, I spent forever trying to find a deal on the contact sets and stuff that I wanted on a maintained operator button and whatever. Because the problem is, you watch that stuff on the industrial control stuff, and anything that's going for a low price is going to get picked up immediately by industrial control dealers or whatever, because they know what they can sell it for to somebody who really needs it and doesn't want to wait for it. But you know, sometimes you get a good deal on it. But if you don't know the numbers on all these pieces for all the different manufacturers, it's really hard to find the pieces that you want. And it is just a complete alphabet soup of you know, designations. So, but the one thing to never trust on the Allen Bradley side is their numbers were always specific. So this is a 509B0D, and that was what they labeled the main component of the starter as is how it was configured at the factory. So it's got all the option codes and stuff in it. So it tells the coil voltage, tells the size, the configuration, whether it was in a can or whether it was open. So you look at that number, you know exactly what you want, and you go find that match on eBay. Somebody may have changed the coil on it. It might not have the same contacts on it. It's no longer in the can. Yeah, and it's actually, you know, it's a lot of work finding starters that have cans on them. You know, it's really easy to find open ones, but in 120 volt. But so you know, that doesn't bother me. Most of the things I have are just wired with control transformers, and so I don't have a problem with the 120 volt ones. But you know, people searching forever because they want a 240 volt coil, or they're hard to find.
I'm having trouble finding control transformers.
Huh?
I'm just having a little trouble finding control transformers.
Yeah, it's hard. The hard part is finding them small enough Or it's nice where you can get the ones that are just a little complete package that, you know, is fully enclosed and whatever, they can just mount on the side of the can. You know, so that it's, you know, and you have just a small transformer, because you don't want a big, huge one. But you need to size them. So these are rated in volt amp ratings. And you need to size the transformer. And if you go look, all the manufacturers will give you the inrush and the sealed coil burden in volt amps. So if you're only doing a single coil, it's easy. But if you're running a bunch of things off of it, like in my phase converter, it's running a bunch of relays, I need to know the draw on every one of those things so that the control transformer is sized, you know, adequately to run all of the control circuits.
Now, most furnace starters have dual voltage coils.
That's the one thing about, yeah, furnace is kind of an oddball in that they have multi-tapped coils that you can change the voltage on. It makes them, or if you don't know what you're doing, looking at them as to, what the hell is all this on here? Because there's a lot more things you got to be aware of when you wire them. But they're pretty consistent in that they have, you know, multi-voltage coils and stuff. Most of the other ones you need to change the coil on. And 120 volt is very common because, you know, in the industrial world, you know, OSHA follows other guidelines, and you're limited to having 120 volt at the operator. So that's, you know, 120 volt and control transformers are much more prevalent in the industrial world, because anything that they're doing new you can't have 240 or 480 volts at the push button. But, you know, if you're running a 480 volt coil, you got 480 volts going out to this. So.
Ray, is there any sort of codex that gives a one-to-one mapping from the 123 EMA to the 95, 97, whatever it is in the IEC? Is IEC consistent enough?
No, IEC is very consistent in their terminal wiring. I mean, so there are all these high numbers. They've got a whole array of stuff depending on what you're doing, you know, in the whole control wiring scenario. So they're very consistent. I think it's, yeah, you know, these are well labeled because it just says NC and it just says 96 and 95 and 96 next to it.
I'm just thinking in terms of, you know, many of us would be using mixtures of, you know, start-stop stations that we happen to have, which might be NEMA devices, and then IEC starter perhaps, or something like that. It's kind of a hybrid. And we might be looking for that 1, 2, 3, and it would be nice to know if 3 equals 97 or something like that. Is that not true?
I don't know. They usually have multiple sets of NO and NC contacts. You know, so that's why there'll be a bunch of numbers on them. And so most IEC devices have multiple contacts, and normally open and normally closed. The Allen Bradley ones like this and a lot of the other brands, they give you the one set you need is just the standard normally open contact set that you need for a rewired circuit for control. So, and then a lot of these things, whether they're identified or not, and most people wouldn't even notice, but like I said, right here, it's stamped in the tie bar is a number 2. And then in looking at this diagram, one is the one that always ties to the side of the stop. So, you know, looking at it, 2, 1, and 3. So, you know, it's an easy thing to identify. But you have to be careful with these kind of boxes, because sometimes they may have been used, if you want to do multiple stop-start stations, depending on your setup, you have to remove that tie piece in the switch, because you can only have it on one of them. So I just noticed that when I was pulling all these out of the drawer, that this one's actually missing it. So I can put a jumper on there, and the side that I jumper is just going to be terminal 2 on here. But that's just something you need to be aware of. On these composite start-stop stations that just have the stop-start buttons in them, like these, are all integrated into one. If you're doing it and you're building it out of the operator type of panel, you know, you're building it out of the box and you're putting all the pieces in it, you always have to provide that jumper in that circuit, because your stop switch and your start switch are going to be separate. But, you know, for most of the things, like this one, this is a 2-speed start stop. And I haven't even looked at this, we just pulled this out of the back of Doug's truck. But it actually, to do 2-speed now, needs a lot more logic in that control circuit. Each of the start and stops need to have a normally open and a normally closed. And they're all getting wired up into the various pieces. I was going to wire this one up. My 2-speed is going to be 2 motors. Well, okay, the one thing I didn't finish on this one. So like I said, this is all based on the same Bulletin 500 contactors, the 596 overload, or auxiliary relays, the overload blocks. It's got the jumpers between here that's connecting L1 to L2, or L1 to L1, L2 to L2, L3 to L3. This is a separate winding 2-speed controller. So it's actually the simplest there is, because all you're doing is going through one contactor or the other. The other piece that's in here is there's a little coordinator in here. So there's a mechanical interlock. So get everything off here. If this one's closed, this one can't move. So it's just another piece, just added on. It just goes right on the little ears on the side here. So there's nothing internal to these that's any different. But they're, so it's all the same pieces. So if you get you need to control a consequent pole motor, now it's a much more complicated, because you're actually rearranging the winding configurations in the logic of what the thing is doing. So it actually requires extra poles on the side of here to be able to make those other connections, and a lot of other things in the control circuit. So there are specific Bulletin 521s for the different types of multi-speed motors, whether they're constant horsepower, consequent pole, constant torque, or separate winding. So if you really need one of those and looking for them, it can be hard to find, especially for those more exotic types. I don't remember the number on the reversing one, but the reversing ones are almost identical to this. It has the interlock and the extra control relays, and then these things actually interchange the power lead. So L1 is going to go to L3, L2 to L2, and so this set of jumpers on the top is a different set because it's interchanging the leads, but otherwise then it's basically the same. You have an interlock and you're controlling them separate, and then off the bottom they're going to have one overload block because your motor is just reversing, the current draw is the same. There's no reason to have 2 sets of heaters. On this one, it's for a separate winding motor that's going to have different current draw, different full load amp values for each winding, so it has a separate overload block for each of them.
So if you found a 2-winding 2-speed starter and you wanted to use it for reversing, all you have to do is twist the...
You could just strip these off the back, off the top, and interconnect them with 3 wires.
Exactly.
Just, so that it reverses.
Right, and then you just have the same rating heaters in both of yours.
Yeah, you'd have the same, and you just need to have the right set of auxiliary contacts, just, logic-wise. I mean, I think you'd end up with the same thing for it. 'Cause there's an electrical component of the interlock, and there's mechanical. Because like I said, you can always, if it didn't have this mechanical interlock, I could go in and trip that other winding while the other one was energized. So this actually then that's why you have the normally open and normally closed buttons and the extra sets of contacts, so that there's an electrical component to that lockout as well as the mechanical. You could go, if you really had consequent pole type multi-speed motor and needed it, you could build all the logic and you could do all the interlocking electrically and successfully run the motor. You could with the right sets of contactors, you can do that logic to do the rewiring. And do it based on looking at the wiring diagrams of how a consequent pole starter is set up. It's complicated, but. And then you can also buy, they make adder poles for these. So there's things that go on the sides of these. And you have to be careful then, because the coils are rated for the number of poles. So if you add too many poles, it needs a different coil to be able to close the adder deck on it. Well, what's really complicated are like the Oliver 51 three-phase headstocks are dual sets of windings. They're constant horsepower, consequent pole, 4-speed motors. So you've got 2 distinct sets of windings. There's 14 leads coming out of the motor, and the switching of the contactors, it has to break the one winding set. You have to break the connections inside the set of windings that you're not using, because otherwise you're generating voltage back coupled from the rotor, and you'll actually interfere with each other if you don't open that other set of windings. So that's even more complicated. I mean, what's all going on inside of that Oliver 51 headstock is pretty amazing. I mean, there's all kinds of contactors. So this one is set up as just a 2-wire control of forward, reverse, or 1-speed, 2-speed. So I just have 2 motors set up because it's like a separate winding 2-speed motor. So this one is actually wired up off of a fan unit that was controlled 2-wire from a thermostat, and you could pick which fan speed it was running.
That's that switch.
That one's breaker for me.
Yeah.
And so this little, it's the exact same thing. It's all the same little components. So this is just one set of normally open, normally closed contacts on here, and it's like the maintained state one, but this is actually 3-state. It's 1 position, mid position where nothing happens, and then the 3rd position. But it's just a different, operator body, same set of contacts. You could, build other things off of here if you needed to do other things, like if you want to control a pilot light or whatever and need an extra switch. You can control the, a light for which.
I need motor wiring for dummies. Is there anything out there that, other than reading days worth of stuff on OWWM? Because I've not been exposed to any of this until today.
No, I think there's a lot of good stuff that people have collected in the OWWM wiki on basic motor starter stuff.
Would be a good place to
Yeah,
start then.
yeah. Like everything with the internet, there's a lot of good information, a lot of bad information. Got to weed through it all.
So when we're looking at a box of old starters, we should be able to tell whether it's just a
Well, that's-
or whether it's a 3-wire.
Well, like this one, okay, here is, Doug pulled this out of the stuff that he was selling. This is a definite purpose contactor. So all that is basically this piece of a starter. So this is designed to be, fully controlled by something else. There's no overload or anything on it. There's no auxiliary contacts. You can sometimes buy them to go on there. But it's funny, I was reading on Square D's website as to definite purpose contactors, and they were actually approached by the HVAC industry. They wanted something cheap. They didn't see the value of putting a NEMA contactor on something that was going to outlive their equipment by a factor of 10. So, these are cheap. They're not meant for a long lifetime or whatever, but that was specifically, they were designed by the manufacturer for a low price point to fit that niche. I really, you can use them for stuff, but I never find much value in these. And most of the starter stuff, I'll admit that I'm the Allen Bradley snob, but mainly because of starting out when I've started looking for all this stuff, trying to wade through all of this stuff, especially on old ones and finding any information of it. It was just something I finally learned the catalog numbers of all the things I was looking for and everything. And you have the advantage that you can actually find the heaters in a lot of the parts and everything. you know, for some of the color hammer and square D stuff, there's so many series of things and whatever, it's really hard to find replacement parts for them or even find heaters. You know, you can always go find heaters and pay, you know, $10 a piece for them or whatever, depending on it. But there's a lot of really old stuff you're lucky to find any heaters for. And the worst ones are the little manual starters that look like a, you know, very similar to this, the little arrow hearts and trumbles and things like that. A lot of them actually have heater elements in them. Those are almost impossible to find a replacement heater for. So if it's actually, you know, has a value that works for you, that's great, but, you know, finding one to actually fit the rating on your motor. And if you don't match it to the motor, it's like, you know, why bother with putting a starter on? I mean, it's there for a purpose. It protects your motor well. I mean, that's your motor's best friend, you know, is having the proper overload set up on it. Like I did, you know, on this. It would have been good for the demo. I wouldn't have wanted to happen. But, you know, I'm running, and like all of a sudden the motor wasn't turning, you know. It was like the motor yesterday, it wouldn't start. And boom, overload relay tripped, you know, because it was trying to start, it wouldn't go, and did exactly what it was supposed to because I lost a phase.
So what are you feeding in right now, 120 volts?
No, they have 240 volt three-phase here. They have a three-phase utility power in here. It's 240 volt. So it was a good example of having a control transformer and everything. The one thing that's missing on here, at some point it depends on the size of it and the size of what you're fed with. This should actually have fuses, 2 fuses coming in. There should be on one on each line coming into the control transformer. That depends on the size. And then there's only one on the output side because it's an isolated circuit. You know, it can only flow through it. It's not bonded to ground or anything. So it can't short from both directions because there's no potential between the secondary winding and anywhere. So there's only one fuse that's needed. And it's like typical of all the Allen Bradley things. It's just a little modular fuse block that attaches right onto the control transformer and just gives you the other output, you know, to it. They actually make a little one that goes on here. It's a Voltage 595, I don't remember, but it's actually a control circuit fuse block that's got 2 little cartridge fuses in it, and it mounts right to the side of the starter. And if you want to buy one new, you know, they're probably $100 or something. Those aren't very common, and I've never gone looking for them.
So is it normal to ground your operator?
Yeah, code-wise for everything, especially you're running, you know, line voltage to it or higher, everything should have a ground path.
Even though, I mean, even though the secondary after control transformer.
Well, on here, if there was the control circuit shorted to ground, it's not going to trip anything because there's no path. But there's no path to you either because it's not common coming through the electrical system. So you don't have a ground path back to it either. So that's a little different. Also on that side, that's one sort of isolation too that control transformer gives you because depending on how you look at that circuit, if you ground the wrong point in there, it can actually actuate the motor. You know, you can short circuit the control circuit and complete this path to the motor just by shorting out one of the wires. So in this scenario, you're not going to do that, but when you're running off a line voltage and it's tied to ground, you can actually create a path by, you know, having the contact in somewhere in the thing and actually close the motor circuit. And also, in the OSHA industrial world or whatever, most everything's done with control transformers too, because there's also limits on the amount of available fault current upstream of you that you can tie a control operator interface to. So in most cases, they just end up needing a control transformer to meet OSHA regulations. You know, it's industrial safety stuff. It isn't in NEC. It's in the other NFPA 70E and 79 that dictates that stuff. And it's not a code issue, but in an industrial world, it's imposed upon. So like at our university, we got all kinds of old machines that are grandfathered, you know, they got 240-volt controls or whatever. But anything new they do, they have to follow the, you know, OSHA required stuff. Any other questions?
Thanks, Ray. Thanks very much.